Hi, everyone. I'm Caitlin Hudac. Oh, great. I took a different approach than Al, who had a very concise talk. I'm going to try to show you all of the amazing things that the work that the families have done for our group. So you'll might hear little teasers of a lot of things. If anything piques your interest, come find me. I might not be in the room because I'm upstairs working with some families throughout today, tomorrow, but I'll be at the dinners. Please come talk with me. I'd be happy to chat. And I also just want to echo my congratulations and thank you so much to the organizers, the Families SCN2A Foundation. This is just such an amazing place. I think I've been coming since Delaware, which was 2018, and it's just such a joy to be here, and it feels like coming home to see all of you. So thank you for being here. So the other kind of big piece is that the reason why I can talk about all of this is because of an Action Potential grant from the foundation. So we're really kind of at that first closing out phase of what that work was meant to do, which was 5 years ago. And with COVID interruptions and me moving labs, it's been a journey, but I'm excited to kind of show you where we are today. Okay. So I run what I've been calling the BioGene study. And our whole kind of objective here is to try to understand and prepare for clinical trials in a way where we're looking at this kind of phenotype and trying to understand what distinct subgroups we might see in SCN2A related disorders. So we could be looking at functional outcomes based upon the actual variant. We could be looking at kind of phenotype subgroups. And really what we're trying to do is understand what's happening in our bodies that might be really, really unique to SCN2A that we aren't also seeing in other groups, right? So we want this to be our SCN2A signatures, and that's what we've been working towards over the past couple of years. So the BioGene study stands for the biomarkers of genetic etiology. It's kind of a mouthful, but we have our own kind of dedicated SCN2A page on our website. And this is really extending from work I did as a postdoc, which if any of you have participated in the Tiger study, I was part of that way back in the day. And then we've kind of moved this into kind of my own lab's work, but we still work really, really closely with the University of Washington. And so we focus on collecting EEG data for the most part, as well as parent surveys. But in the next kind of iteration of what this looks like, we finally have some clinicians on my team who you'll meet one in a picture in a little bit. And so we will be moving more into helping and working closely with other folks that are actually characterizing those clinical phenotypes. So I think that that's going to be phase 2, so stay tuned for that. But we have been asking parents about what behaviors they're seeing in their child, and we're mapping those on to kind of what we're seeing in the brain. And as this little baby, this is from my dissertation way back when, but we use a style of EEG net that is not glue. It doesn't take a very long time. We use it because it's very easy for our kids, and even those that have sensory sensitivities seem to kind of work with this. And we also have recently kind of figured out how to use this style of net with folks that have twists or locks or afro-textured hair. So we're really not excluding anyone. That's a big focus for us to make sure, particularly in our rare populations, that anyone that wants to do research can. So some of you have seen me in your homes because with the funding from Families SCN2A Foundation, I took my EEG system on the road and traveled all across the country to see you. So this is post-pandemic. You can see the little video. This is also on our website. We wanted to make this something that was not a burden for the families. So in a 3-month period of time, I was all over the place. And even though we only started with about a dozen or so families who said yes, you posted on social media and told everyone that I was coming, and I kept getting phone calls, and we worked our way up to seeing over 50 individuals, and most of them being kids with either SCN2A or GRIN2B mutations. And it was such a rewarding experience that this is where we are today. So we have seen over so by Saturday, we will have seen over 70 individuals, which is incredible. And this is including kids that have come in and done multiple sessions with us. So we have over 100 sessions altogether. And you can kind of see the breakdown, and I tried to kind of highlight how this looked over time. The Tiger study was a great jumping off point, and we've been seeing many of you at these family meetings, and I hope to continue seeing you at these annual meetings as well. And you can see one of our participants over time, starting at that Delaware conference all the way until I think that's Columbus in 2022. So this is the information that we're collecting from the EEG. This is not a seizure assay. We're using the EEG to understand how the brain is working to process information. And so we have these three kind of experiments. It takes about 20 minutes, let's say. I think we've been running kids in and out even today in under 25 minutes. So we're getting pretty fast at this. So we have reasons for doing each of these tasks, and they tell us different information about how the brain is kind of processing information in the world, but then also how is it growing? So EEG is a really cool way to kind of track ongoing maturation over time. So to hopefully move forward. Not sure why there we go. Okay, so here's some recent findings. We had a paper come out last year where we were looking specifically at that parent report data. And I'm just going to kind of give you some of these highlights because there's a couple really kind of fun little nuggets. So here we were looking at trying to understand the sensory phenotype, and in SCN2A in particular, we're seeing this kind of that our kids do not necessarily have sensory registration problems. So it's not that they're necessarily not noticing that there's these new sensory information in the world, but they tend to have more sensory sensitivity. So they have more extreme reactions to the things that they see. And this is related to a couple of other gene groups, as well as an idiopathic autism group that doesn't have any known genetic etiology. And then this is kind of a new finding. This actually came out yesterday. So we now, I think, have, Sean, was your number 72? So we have 73 papers from our group here. So this is one of the, a study that we did during the Seattle family meeting for those that were able to come to our lab group and do the eye tracking. So we looked at 5 SCN2A participants who had both the EEG piece as well as the eye tracking piece. And so what we do is we play these sounds for kids over and over and over again. And what we do is we say, okay, so at this exact moment where that kind of vertical line is drawn, we say, what is the brain doing at that moment? And then we are able to see kind of the electricity within the first half a second even. And this is, we're going to talk a little bit about this P3A component, which is an attention component. So we see this very, very big response in response to things that are kind of like pop out sounds, things that you haven't heard before. And what we see in SCN2A, which you can kind of see in this far left panel, is a much bigger response than both our autism group and our neurotypical group. So I just kind of drawing this vertical line to show you how heightened this reactivity is. So we see this very big attention response in these 5 SCN2A participants. But then we also had them go next door and watch these videos. So they saw videos that look something like this.
Why aren't you wearing a sweater today?
And no sound.
I forgot to bring it with me.
They're having a conversation.
Did you wear a sweater today?
I wish I wore my coat today. The wind outside was so cold.
So there are these 15-second snippets, and what happens is they're having a conversation, there's 3 people, and then at one point, one of the speakers looks to the camera and says something direct to camera. And that's what we call a conversational bid. So it's a way of which we're asking the person, hey, there's something social, we're trying to communicate with you now. And so what we can do with eye tracking is we look through at each scene, and we've coded them all up to look at faces and bodies and hands. And what we found is that whenever you have that shift in attention that we expect, we're not seeing that condition effect in SCN2A. So at the group level, there's no difference whenever the people are talking to each other or when somebody's talking directly to camera, directly to our kids. Now, I say that at the group level, but hopefully you can see in this graph that I've drawn the individuals. So there's 2 individuals that actually show this effect very strongly. And that's something that we've dig out a little bit more in the paper. But we're really excited because Here we go. If we look at kind of the EEG attention response, that shows us auditory response, and then we look at the eye tracking visual attention response, we see in the SCN2A block and up here in the corner is that we're seeing this larger visual effect. So if you have a bigger visual attention effect, it's actually related to reduced auditory attention effects. And that's pretty unique to SCN2A. And this wasn't significant. It's only a couple of kids. But I think that this is starting to show us that we could really need to be looking not only in our auditory domain, but understanding, and we're going to hear from Kevin next, I think is talking about eye tracking. So understanding why we need not only auditory attention, but thinking through the visual system as well is going to be very, very important. Okay, now I'm probably running slow. So some other kind of cool things that we're doing. So we're working with the Netta Shanks group at University of Radboud in the Netherlands, and they use the fruit fly to understand really complex behaviors related to different genetic conditions. And this is work that her student, Laura Block, has been working on, where they've been knocking down the fruit fly. And she, I'm not sure the video will play, but she takes the flies and she puts them in this little light tube, and then we shut off all the lights, and then the flies see this really annoying flashing light. And what happens is at first they jump a lot, and this is a little different than their startle assay, but what you see then is over time that the system kind of resolves over time. And what they're able to do is say, okay, for the flies that have the SCN2A knockdown, which one of these responses are they showing? Are they showing this kind of sticky attention effect that we see in autism, this atypical line? Or are they showing no difference from the wild type fly? Or are they showing this like really large initial response and then they don't jump at all? And it turns out that the SCN2A ortholog, that fly, is showing that kind of yellow line where they're showing this kind of severe response where it's a big response at first and then they stop jumping for the most part. So we're starting to work that up and link it back to things like the Vineland and understanding how the human attention response also maps onto this. Okay, so in the last couple minutes, I just want to tell you a little bit about where we're going. And this is my new grad student, Sophie Kramer-Benjamin. She had a wedding this weekend and couldn't be here, but she's so excited to meet you all. She's really focused on understanding autism and intellectual disabilities using these biomarkers. So I'm sure you'll be seeing her very shortly. She's just really pumped to be joining us. So here's some of the things that Sophie and I are planning to work on. So I showed you about that strong P3A effect. This is a little bit different of a waveform because it has more of our participants in it. But the thing that's really exciting about EEG is that we don't look at just one thing. So in that half a second, we can actually look at a lot of different kinds of responses. So what we're working on at the end of this weekend is really understanding and characterizing that neural response in SCN2A from our 70 participants over time, right? So understanding those detection effects, that kind of attention orienting, but then also how we chew through that information and these kind of ongoing cognitive markers. The other big piece is that we're using that resting state data, which is just EEG recorded while our kids are being still and chill. And we're planning to look and understand a little bit more about kind of general brain organization. And we're using this marker that's become really well known in autism to look at excitatory versus inhibitory responses. So these are neurons that are either excitatory and kind of have this ongoing action, or inhibitory where they're kind of dampening down other action potentials. And what we can do is we can look at that EEG data from us and we plot it in this little spectrograph. Basically what we're trying to understand is that slope from the left side to the right side. And based upon that slope and how steep it is, we can look at the excitatory pathways that are kind of governed by glutamatergic activity, or this inhibitory response that's GABAergic. So if you have more excitatory activation, you might see a slope that looks kind of like this. But if you see the opposite, we actually see a much steeper response. And so each of these pieces actually are mapping on to autism symptoms in other groups, particularly in infants. So we're really excited to understand and unpack what we're seeing in SCN2A. So that's to come. The other thing is, anyone who's met me, the reason why I come back and I'm always bringing my sister with me is that it's really important to understand development. So we've been hearing from families that have navigated puberty in our kids. We don't really know what puberty in the brain in SCN2A looks like, right? So what I'm showing you here is at least a portion of the kids that have participated with us, just kind of rank ordered by age, with the youngest starting age kind of at the bottom of the graph. And you can see the ones that have the lines with multiple points have come in for multiple visits. So this is one of the things that we're hoping to do, because when you start to look kind of vertically between like age like 6 to maybe 12 or so, you see across all of the kids, we have a lot of data, but we're also starting to see that longitudinal data collection. And what we really need to do, what I'm really excited about, is writing grants to understand this from a more dense perspective. So kind of seeing kids and testing day 1 and day 2. So we know if these are reliable signals, or is this just you had a cranky day? So having that information is what we need to really build these as preclinical markers that we could use in things like clinical trials, but then also following everyone maybe 6 months later and really getting this depth of understanding of what in the world is going on across development for our kids. So last slide, just wanted to kind of throw up some of the ideas and what's in my head, because I'd love to have these conversations with everyone here over the next couple of days. I love the EEG work that we do, but is this the right tool? Like, I love that we can go to your house. I love that I can bring it here. I can't do that with an MRI. But we want to make sure that we're doing science from this kind of electrophys side that makes sense for what the families need and want to see. So for example, Sophie's really, really excited about emotion dysregulation. So if that's something that also kind of jives with you, that's one of the things we'd like to kind of start thinking about and working on, is trying to understand maybe how our SCN2A kids manage new things and are kind of regulating their body and their minds and their emotions. And I just want to kind of underscore the fact that we really want these biomarkers to be inclusive. So that means that the folks that aren't near cities, in these rural areas across the world, we want to be able to include them in research. We're happy to chat with everyone about what this looks like and reduce the barriers for them participating. So if you have or know of families that are kind of on the fence about participating in research, we'd love to talk to them and just hear their side and understand what those barriers are for them. So we could either address them in the work that we do or find accommodations for them. So with that, I want to thank everyone. I'm not sure if Carson's still here in the room, but that's Carson at the dance party last year. So we'll be on the dance floor in a couple of days. Just thank you again for being here and listening to all of us scientists. We really appreciate you.